Tonight, a stark warning that artificial intelligence could lead to the extinction of humanity.
I'm very close to the cutting edge in AI, and it scares the hell out of me.
Have you ever wondered what could happen if we brought together two revolutionary technologies, AI and quantum computers? It's both exciting and scary. Recently, the US government stumbled on something unsettling and has taken an intriguing step, urging Google and NASA to halt their quantum computer development efforts. This is something that many prominent figures, including renowned physicist Michio Kaku and Elon Musk, have been warning about for years.
Anyone who's interested in security is interested in quantum computers. They can crack almost any code that is based on digital technology. That's why the FBI, the CIA, and all national governments are following this very closely.
What's going to happen? Join us as we uncover the truth about quantum computers and AI.
I said, well, what about, we're going to make sure humanity's okay here. And then he called me a speciesist.
Quantum computers are captivating devices that operate on the basis of quantum mechanics. Unlike conventional computers that use bits to store information strictly as zeros or ones, quantum computers use qubits. Qubits can represent zeros, ones, or both at the same time, which fundamentally differentiates them from traditional bits. What makes qubits so special is their ability to exist in multiple states at once. This is thanks to a phenomenon called superposition. This means they can hold information as both 0 and 1 simultaneously, making them highly significant in the quantum computing world. With these superpowered qubits, quantum computers are capable of handling complex calculations in parallel, offering a potential speed-up for tasks that would take classical computers much longer to complete. But that's not all. Entanglement is another amazing aspect of quantum computing. This quantum phenomenon links multiple qubits together in such a way that the state of one becomes closely tied to the state of the other, no matter how far apart they are. They utilize the amazing capabilities of qubits to process information in an entirely new and fascinating way. Traditional computers, which work with classical bits, can only deal with either 0 or 1 at any given time. Quantum computers, on the other hand, leverage the power of superposition and entanglement to deal with a lot of information all at once. However, something shocking has just occurred. Just now, NASA has shut down quantum computers after an unexpected incident. Tracing back the origins of this quantum revolution, we find ourselves in the early 20th century. This was the time when the groundbreaking quantum theory first emerged. The quantum theory dives deep into the complexities of atoms and subatomic particles, trying to build a whole new perspective of how we see the world around us. Back in 1900, Max Planck came forward with a radical idea. He proposed that energy is quantized, coming in discrete packets rather than as a continuous flow. This laid the foundation for understanding that particles like electrons can only exist at specific energy levels. A few years later, Werner Heisenberg shook the world with his uncertainty principle. This principle stated that you can't know both the exact position and momentum of a particle at the same time. After these developments, the quantum world kept the scientists of the entire world on their toes. In 1935, Albert Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, introduced the EPR paradox. They highlighted the peculiar behavior of entangled particles and their instantaneous communication, regardless of distance. However, it was really in the 1980s when quantum computing took a giant leap. But how did this happen? All it took was the emergence of revolutionary ideas on how to utilize the power of quantum mechanics for computational purposes. Physicists like Paul Benioff and Richard Feynman envisioned computers operating in the quantum realm. These computers would be capable of performing calculations at speeds unimaginable for classical computers. This vision sparked curiosity and laid the groundwork for decades of research and exploration in quantum computing. By 1994, mathematician Peter Shor developed an algorithm that demonstrated the true potential of quantum computers. This brought Benioff's and Feynman's dreams to reality. Certain problems could finally be solved much faster than classical computers. The first practical glimpse of a quantum computer came in 1998. A team at the Los Alamos National Laboratory created a 2-qubit quantum computer using nuclear magnetic resonance techniques. Though it had its limitations, it was a major breakthrough in the journey of quantum computing. As we stepped into the 2000s, the field of quantum computing saw remarkable progress. Multiple research groups and companies strive to create more advanced quantum computers, achieving several breakthroughs. In 2001, IBM introduced a 7-qubit quantum computer, impressing both scientists and tech enthusiasts alike. Following this, the quantum community turned its focus to quantum error correction. This aimed to protect quantum information from any sort of outside disturbance. By developing codes like the surface code, they provided qubits with a protective layer, making quantum computers more reliable. By 2005, researchers had built a working quantum computer with 5 qubits, demonstrating that practical quantum computers were within reach. But this seemed to be just another beginning. In 2007, scientists at Yale University broke new ground in the world of quantum computing. They discovered a way to create stable qubits using solid-state systems. These materials are much easier to handle and more stable than previous options. They had found a new way of making quantum computers much more user-friendly. Fast forward to 2010, and the University of Science and Technology of China shook the world. They achieved quantum teleportation. But how did they achieve this? This milestone was achieved by transferring quantum information from one particle to another over a distance of 10 miles. This remarkable feat opened up possibilities for building quantum networks capable of transmitting quantum information across vast distances. In 2013, Google and NASA decided to join forces and work on a groundbreaking project. This would be the D-Wave 2 quantum computer. However, they faced an unexpected hurdle when a government shutdown put their work on hold. The quantum computer was left in a state of limbo. This was even worse because the cost and time needed to bring things back to normal were huge, to say the least. Despite this setback, Google, which had invested in the Ames Quantum Artificial Intelligence Lab and had access to a quantum computer, faced uncertainty about its future projects due to the lab's closure. The government's decision to suspend activities had significant impacts. But the story didn't end there. With government operations eventually resuming, the D-Wave 2 quantum computer was ready to make a comeback. It seemed that the dream of exploring the quantum frontier was alive once again. In 2019, Google stole the spotlight as it showcased the incredible power of quantum computers for specific tasks. This breakthrough inspired tech giants like IBM and Microsoft to increase their efforts in quantum computing, creating a competitive race to develop better and more reliable quantum systems. IBM made a splash in 2020 with the unveiling of the IBM Quantum System 1. This would be the first fully integrated quantum computer designed for commercial use. With such a breakthrough, it was bound to draw attention. But that wasn't the only thing it brought. It also brought large investments from governments and industries around the world. Governments couldn't stay away from the appeal of quantum technology. They saw its potential for game-changing applications. This eventually led to the funding of quantum research initiatives and the establishment of research centers and labs. These labs and centers encouraged collaborations among academia, industry, and government agencies. In today's scientific community, there is a shared belief that intelligent life might exist on other planets, possibly using black holes as powerful supercomputers. With such opinions floating about, it seems that the journey into quantum computing continues to be an intriguing adventure. At the same time, the Fermi paradox has left scientists scratching their heads for quite some time now. With the vast expanse of the universe, the likelihood of other life forms existing seems pretty high. Yet, we've not come across any solid proof of their existence. The Hart-Tipler conjecture tried to solve this riddle, suggesting that if advanced alien civilizations were out there, we'd surely see some traces of their activities. This is when a team of physicists from Germany and Georgia with a fresh perspective entered the picture. They proposed that these advanced civilizations might be utilizing black holes for advanced technology. Since the 1960s, our search for extraterrestrial intelligence has mainly involved scanning the cosmos for radio signals. However, some scientists believe we should widen our net to include other signs of advanced technology. These may include things like directed energy, neutrinos, quantum communications, and gravitational waves. Jad Valley and Zaza Osmanov's study introduces the concept of large-scale quantum computing as a potential way to detect these advanced alien civilizations. Quantum computing is considered an ideal tool for advanced civilizations, and rightly so. They may be using black holes as perfect environments for quantum computing. These miniature black holes, possibly created by these advanced beings, would emit intense radiation, including Hawking radiation. This radiation, along with high-energy neutrinos, could be our ticket to spotting advanced civilizations. Our detection tools, such as the Ice Cube Observatory buried deep in the ice of Antarctica, could play a crucial role in this venture. This theory could very well be the key to unraveling the fairy paradox. It could explain why we've not yet stumbled upon signs of advanced civilizations. If these cosmic neighbors have transitioned from traditional communication methods to utilizing black holes as their quantum supercomputers, it would make sense why we've been unable to detect them. As their computing technology evolves, they might only use radio signals for a short period. Dr. Michio Kaku, a renowned theoretical physicist, has also shared his insights on quantum computing. He highlighted the potential of quantum computers to check the accuracy of information generated by AI chatbots, enhancing the reliability of results. However, he raised concerns about who controls this fact-checking power. He was concerned that governments might use it to silence opposition. It seems that quantum computing is a double-edged sword. On one hand, it has immense potential to benefit society. On the other, it holds the power to be used for control and deception. The development of AI has brought us advanced tools like AI image generators and chatbots. Yet, it has also given rise to dark phenomena like deep fakes, which spread false political information at an alarming rate. We also have the example of AI trading bots, which can disrupt stock markets. Law enforcement AI tools can lead to over-policing and biased decisions, further worsening social inequalities. Yet there's hope on the horizon. Scientists worldwide are working hard to build the ultimate quantum computer. This work involves experimenting with different materials and specialized devices to enhance its performance. Despite these challenges, maintaining quantum coherence is vital for accurate computation. This obviously requires highly controlled and isolated environments at super low temperatures. Error correction is also a critical aspect of quantum computing, and researchers are actively exploring ways to tackle errors and enhance their reliability. It also represents a revolutionary leap in technological advancement. As mentioned before, it goes above and beyond the capabilities of classical computers. Governments, academic institutions, and private companies have recognized this potential. This has allowed for a collaborative environment to propel quantum research forward. Leading tech giants like IBM Quantum, Google Quantum AI, and Microsoft Quantum are at the forefront, providing researchers with unparalleled access to state-of-the-art quantum hardware, software, and educational resources. Scientists in the field of quantum computing are continuously working to create new quantum algorithms and software. These developments are gradually helping us tap into the capabilities of quantum computing. As we advance, the applications of quantum computing are expanding, with potential impacts on areas like machine learning, cryptography, and drug discovery. Imagine a world where computers operate at unimaginable speeds and efficiency, solving complex problems in the blink of an eye. One of the areas where quantum computers are proving to be invaluable is space exploration. They enable us to simulate and model astronomical phenomena with unparalleled precision and speed. They are also able to offer deeper insights into celestial bodies and cosmic interactions. This not only enhances our ability to carefully plan space missions, but also aids in optimizing trajectories and predicting the movement of space debris. This ultimately allows for safer and more successful missions. The profound impact of quantum computers extends to the realm of cryptography. It is an essential component of space exploration and secure communication. Traditional cryptographic algorithms are at risk of becoming outdated in the face of quantum computers. However, quantum cryptography ensures the creation of secure communication channels. Being equipped with properties like entanglement and superposition, it safeguards sensitive information during space missions and beyond. They also open up new possibilities for efficient spacecraft propulsion through quantum tunneling. Also, it can also use optimization of logistics, materials design, and simulation of nuclear reactions. Machine learning on quantum computers takes a quantum leap, enhancing decision-making, pattern recognition, and autonomous systems. This is crucial for mission planning and resource allocation, making quantum computers cosmic enablers that open new horizons in space exploration, security, and technological advancement. In the fascinating world of quantum sensors, these devices act like advanced trackers, enhancing target detection and tracking with exceptional precision. Quantum communication, on the other hand, acts as a cosmic security system, ensuring real-time analysis and data processing on the battlefield. This contributes to unparalleled situational awareness, enabling informed decision-making in cosmic conflicts. While the field of quantum computing is still in its early stages, its potential to enhance military capabilities is undeniable. However, with great power comes great responsibility. Alongside the promise of quantum computing are potential threats and challenges that require close attention. A major concern revolves around the threat to encryption systems, which are vital for securing sensitive information and maintaining data privacy. Secure communication protocols used in online banking and government agencies rely on complex mathematical processes, and quantum computing has the potential to disrupt these, which makes the development of quantum-resistant encryption methods a necessity. Classical computers, which we've been using for decades, are now facing a significant challenge. The world of encryption, which is crucial for securing our confidential information, is at risk. Quantum computers are stepping onto the scene, and they're changing the game entirely. Unlike classical computers, quantum computers have the incredible ability to perform complex calculations at an unimaginable speed. This is particularly true when it comes to encryption. Encryption protects our financial data, confidential information, and personal details from unauthorized access. It works as a difficult problem that takes regular computers a long time to crack. But quantum computers have the potential to break these encryptions much faster, using algorithms like Shor's algorithm that can quickly factorize large numbers, which is a process that classical computers find very slow. Imagine this: if quantum computers get into the wrong hands, all of the confidential information that we believed was secure could be exposed. This scenario is alarming, especially when you consider the world of cryptocurrencies. Bitcoin, a well-known cryptocurrency, relies on cryptographic algorithms to secure transactions and maintain the integrity of its digital currency. However, the sheer power of quantum computers could potentially break these algorithms, putting the trust and reliability of cryptocurrencies at risk. This could lead to significant disruptions in the digital economy, a scenario we must prepare for. As quantum computing advances, addressing encryption vulnerabilities becomes essential. Experts worldwide are actively developing what's called post-quantum cryptography to safeguard data against the power of quantum computers. It's an ongoing effort to balance the strengths of quantum computing with the necessity of data security. Our goal is to keep the digital space stable and protect sensitive information. These new cryptographic techniques aim to be resistant to quantum computing's capabilities, ensuring that our encrypted data remains inaccessible to even the most advanced quantum machines. The progress in this area is critical, not just for protecting current communications, but also for securing historical data against future threats. The race is on to establish these security measures before large-scale quantum computers become a reality. Data privacy is also at stake. With their immense computational power, quantum computers have the potential to uncover patterns and correlations within large data sets, even if they are encrypted or anonymized. This presents a significant challenge for individuals and organizations that rely on data privacy to protect personal information and trade secrets. Potential breaches of data privacy raise serious concerns about ethics and the necessity for regulatory frameworks to safeguard our rights and prevent the misuse of sensitive information. Quantum computers have the power to disrupt the foundations of scientific simulations and models. These simulations hold a great potential for revolutionary advancements in material science, drug discovery, and climate modeling. However, if quantum computers become powerful enough to break through the encryption protecting these simulations, unauthorized access or alterations to sensitive information could occur. This challenge could have a profound impact on scientific research, innovation, and decision-making. There's no need to panic. Scientists and cryptographers are hard at work developing encryption that can withstand quantum computing attacks, known as post-quantum cryptography. They are focused on making sure that our online communications stay safe and private in the face of emerging quantum technologies. Their work is essential in preventing the potential decryption capabilities of quantum computers, aiming to secure networks and information against future threats. As they make strides in this field, they help ensure that the transition to a quantum computing era does not compromise data integrity or privacy. Quantum computers offer impressive computational abilities that present new opportunities for exploration. At the same time, they challenge us to enhance our methods of protecting our digital environment. The increased power of these machines requires stronger security protocols to keep our information safe. As such, the development of robust encryption standards is now more critical than ever. This ensures that our digital infrastructure remains secure even as quantum computing continues to evolve. Facing the challenges posed by quantum computing, a global community of experts and researchers is dedicated to developing advanced post-quantum cryptography. Their objective is to create strong, secure defenses to counter the powerful computing abilities of quantum machines, aiming to keep our digital information secure. Friends, thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable